today we're going to learn about complex numbers and roots. We will define what complex numbers are, and we're going to be using imaginary numbers. Imaginary numbers come from negative square roots. Remember earlier this year we tried to take a negative square root? Do you guys remember what your calculator would tell you? Yeah, there'd be an error, right? It was a domain error because you cannot take the square root of a negative number. So we have come up with a symbol to represent a negative square root, which allows us to rewrite the roots using imaginary numbers. Okay, so that's what we are going to focus on today. Alright, so the first thing we're going to do is define these. Okay, we're going to do that part together. So an imaginary number takes the place of a negative in the square root. So we are going to denote the letter I to the imaginary numbers. Do you guys need any more time to write out the title? Alright, so then let's do the definition. Okay, so the square root of a negative number is the definition of an imaginary number. Okay, so an imaginary number is the square root of a negative number. And then this is represented by I. So that's going to be our symbol. Represented by I. And in many ways, we're going to treat it just like we would any other variable. Okay? So we are going to let I equal the square root of negative 1. Okay, so I is going to equal the square root of negative 1. Based on that, let's come up with what I squared is going to equal. Okay, so if we have I squared, and we know that I is the square root of negative 1, if I were to plug this in, wouldn't I squared just be the square root of negative 1 squared? Do you guys know what that would equal? Yeah, just negative 1, because the square undoes the radical. So that means I squared is equal to negative 1. We're going to be using that later on. That is a big thing, because if we can represent a radical as a whole number, that's going to help us do some simplifying. Okay, and then in example 1, we are going to express each number in terms of I. So we are going to be simplifying each of these terms. Alright, so for A, we have the square root of negative 16. Now the first few times we do this, I'm going to go like really slow, and then as we become more comfortable, we're going to speed it up a bit. Okay, so like I said, the square root of negative 16, we can rewrite this as the square root of negative 1 times the square root of positive 16. Remember that with multiplication, when we're simplifying radicals, how we rewrite it? So now we can simplify each one. Okay, so if you have the square root of negative 1 times root 16, the square root of negative 1 is going to be what? Well, we just learned that the square root of negative 1 is equal to? No? I. So the square root of negative 1 is I, so this is just I times root 16. Okay, well what's the square root of 16? 4. Okay, so this is the same thing as I times 4. And the way that we write that would be 4I, just like we do every other variable with a number. So it becomes the coefficient. Okay, can you guys think of questions for me at this point? Alright, we're gonna try another one. So you have the square root of negative 24. Okay, and the square root of negative 24, let's just start it exactly like we did the last one. Okay, and then after this one, I'm going to skip this step. Because if we know that the square root of negative 1 is I, really, I want you guys to get comfortable just jumping to I root 24. Okay, and the rest is going to be just like what we did the other day where we were simplifying radicals. So I want you to simplify 24. You can decide how you want to do it. Yes? Yes? Yep.
Thank you.
Thanks. And then homework is okay, so for the square root of 24, okay, you are going to find the perfect square that's in 24. Will you guys raise your hand if you like doing the factor tree? Okay, raise your hand if you like finding the biggest perfect square. Okay, good. So about half and half. So you guys can decide what you want to do. Rashawn, how do you like to do this? Okay, so walk me through it. Okay. Oh, okay. Okay. Good. So if there's 2 2's, that goes on the outside. And then how do you know that the 6 is on the inside? Yes. So you're going to multiply those. 3 times 2 will be 6. Good. Okay, and then the other way you can think of it is you can do root 4 times root 6, which will be 2I root 6. So if you're doing it the factor tree way, all you're going to have to do is I times this. I times 2 root 6 is going to be 2I root 6. This is going to be your final answer. Okay, and I do not care which way you want to do this. Okay, if you do your factor tree, then you would show me this work here. If you find the biggest perfect square, you would show me this work here. Okay, so it doesn't matter, just whichever one. Okay? All right, so for C, we have negative square root of negative root 96. So now we have this value on the outside that we're going to keep on the outside. So that negative has to stay there. Okay, and then instead of writing the square root of negative 1 again, can I just write I root 96? Are you guys with me with that part? So anytime there's a negative in the radical, we can replace it with I. If there's a negative in front, that has to go with it. Okay, and then I want you guys to simplify the square root of 96, so I'm going to give you a minute to do that. Okay? So if you want to use the perfect square method, sometimes what I recommend is just generating the list of perfect squares that you're checking. So 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. I usually go up to 100, so 10 squared. Okay? And then if I'm trying this and I try the first one, if I try 4, yeah?
We want to take a picture for your book and your outfit, but you can do it.
Can you come back the last 10 minutes? That'd be awesome.
Yes.
Thank you.
Of course.
So for 96, if you're checking the biggest perfect square, do you guys start by checking the 4? Okay, so what's 96 divided by 4? Will you guys do that for me? Okay, so if 96 is 4 times 24, do you guys know how to decide whether this is the biggest one or not? Yeah, see if there's a perfect square that goes into 24. Is there a perfect square that goes into 24? Yeah, what is it? 4. So there's a couple different ways you can do this. So I'm going to show you the different ways. If you say to yourself, oh yeah, well 24 is root 4 times 6. Really what you have is the square root of 4 times the square root of 4 times the square root of 6. And there's no perfect square in 6. So you would just simplify. What's the square root of 4? 2. So it's 2 times root 6, which will be 4 root 6. Okay, you could also say to yourself, oh, I know that 4 goes into 24. What's 4 times 4? 16. So 16 is the biggest perfect square that goes into 96. 96 divided by 16 is 6. And you could think of it that way. Okay, so either way is fine. And then you could also do the factor tree. When I do the factor tree, I always start with 2. Right, so 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. Now with this one, this is the first factor tree one, I think, where we have multiple pairs. So if you have one group of 2, that comes outside. Your other group of 2, that comes outside, and you multiply these together. And then it's times the radical of 2 times 3, so you would get 4 root 6. So again, you can choose what method you want. Choose your own adventure here. Okay? So you have negative I times, and then I'm just going to rewrite this. We just did this work here. So 4 root 6 is what we simplified for 96. Okay? And then from there, you will have negative 4I root 6. All right, what questions do you guys have for me about that one? Okay, so understand that the work I did for this was over here. Okay, so root 16 times root 6. And then I simplify. Questions for me yet? I know we're just kind of taking it all in. You try D, okay? So I have 5 square root of negative 121. And if that 5 in front is confusing you, just ignore it. Just simplify the radical part first. let's see how we're doing. So, like I said, we're going to just ignore the 5 for right now. It's going to be chilling here on the outside. With the square root of negative 121, that is going to be I times the square root of 121. What's special about 121? It's a perfect square. What's the square root of 121? 11. So this is 5i times 11. So once you take the square root, that comes out of the radical. And then you just have to multiply the number by the number. So 5 times 11 is 55. So 55i is your final answer. All right. Do you guys have questions for me on that? All right. Let's try E. I think I heard you guys say that you wanted some fractions in there. So here you go. We got some fractions. And again, just simplify the radical first, and then we'll apply the fraction, okay? Okay, so if we haven't simplified the square root of negative 12, I want you to do that. And then we are going to be multiplying it by the fraction. So just think about, how do I multiply a fraction by a whole number? Okay, so we are going to do root 12. So I'm going to leave the negative 1/4 in front. Okay, and then when you have the square root of 12, we are going to simplify that. Okay, so what's the biggest perfect square that goes into 12? Okay, so this is root 4 times root 3. So when we simplify it, I'm just going to put this part in the parentheses. This is going to be 2 root 3, so we would write it as 2i root 3. Okay, so however you simplified the square root of 12, you should have got 2 root 3. Are you guys okay with that part, the 2 root 3? Feeling good about that? Okay, so now because we have the I, look and see where the position is. Just like if you have any other variable, it goes behind the number there. Okay, but in front of the radical. So now what we're going to do is we're going to multiply negative 1/4 times the 2i. So we're multiplying the negative 1/4 times 2. Do you guys remember the rule when you're multiplying fractions? Multiply the whole number by what part of the fraction? Yeah, by the numerator. So if I do 2i times negative 1/4, it's going to be negative 2i over 4. What's negative 2 over 4 reduced to? Yep, so it's negative 1/2 times I root 3. Okay, now if you got here, this is great. We just have to go one more step to simplify because we have to multiply these two together. Okay, so again, you're multiplying the whole by the numerator of the fraction. Okay, and you could either leave your answer like this, or what we are going to want to start doing is putting the coefficient of I first. So the number here is negative root 3 over 2, and then we would put I on the side. So this is similar to in Algebra 1, when you were finding the slope of something, and you had like x over 2. Your teacher might have said, oh, we're going to write that as 1/2 x because we want to see the slope. This is similar to that. We want to see what the imaginary coefficient is. Okay? And so either one of these would be acceptable. All right, questions for me on the first example? All right, let's solve equations now. Okay, so for example 2, we are going to solve. So for A, we have x squared equals negative 144. And then we want to get the x value by itself. Okay, so Ashley, if I have x squared and I want x, what do I do to x squared to get x? Yeah, you're going to take the square root of both sides. So let's do that. So if I take the square root of x squared, I get x. Now remember, one of the main things we talked about yesterday, if you take the square root, what do you have to have in front of it? Oh, plus or minus, yep. And then, yes, we do have to have the I today. So because this is negative, it is I root 144. What's the square root of 144? 12. So this is just plus or minus 12i. Okay, and that's going to be your final answer. All right, let's go to the back. We'll go to part B. All right, so we have 5x squared plus 90 equals 0. Okay, I want you to see if you can do that one on your own. Okay, so Julian, will you help me with this? Will you tell me your first few steps? Great. All right, and then Julianne, what'd you do next? Okay, so before you take the square root, we want to move that 5 over. We don't want it under the radical because it's not a perfect square. So before you take the square root, let's divide both sides by 5. Okay, and then Aiden, if we divide that by 5, what do we get? If you do the negative 90 divided by 5, what did that give you? Okay, good. All right, now, once you get here, you can take your square root. Okay, so I have x equals, and then don't forget your plus or minus. And then if you want, at this step, you can do plus or minus I root 18. So you can replace the negative with I, and then we have to find the biggest perfect square that goes into 18. Gwen, did you find the biggest perfect square for that? Yeah, so square root of 9 times square root of 2, which would be 3I root 2. Okay, so again, once you simplify this to 3, the I is going to go behind it. So you have plus or minus 3I root 2. All right, let's try some more fraction work. So 1/3 x squared minus 5 equals 0. Okay, so think about how you want to move the fraction over. Okay, so Maya, what did you do first for this one?
I added
Good. So when we add 5, we have the 1/3 x squared equals 5. And then when you're moving the fraction over, what rule do you guys use to do that? Oh yeah, do some of you divide by 1/3 and do the keep change flip? Yeah, absolutely, you can do that. What else can you do? Yeah, Lizzie?
just multiply both sides by
Okay, why 3? What's the significance?
the
Yeah, and if I multiply both sides by the reciprocal, what happens when I do 3 times 1/3? What do I get? What's 3 times a third? I just get 1, right? So it's 1x squared or x squared. Now, did you notice this one? It's not a negative. Did you guys put the I in there, or did you remember? You remembered? It only happens if you have a negative. Okay, so if there's no negative, you're not going to put the I in there. Okay, so pay attention. Make sure that you don't just keep adding it. And then for root 15, you can't split that up into the square root of 5 and the square root of 3. Anybody tell me why not? Yeah, Julian? Yeah, neither of them are perfect squares. Like, that wouldn't make sense. The whole part of rewriting with multiplication is to pull out the perfect squares, to simplify that part. So if there's no perfect square, you are just going to leave it. Okay, the last one we're going to do some of it together because it involves something that you did in geometry that some of you may or may not remember. So we're going to work our way through that. So we have 6x squared minus 2 equals negative 7. 6x squared minus 2 equals negative 7. Okay, so who help me start this one? What am I doing first?
Adding to both sides.
Yep. So 6x squared equals negative 5. All right, and then again, because you have a number in front of the x squared, you just want this to be x squared, so we're going to divide, and that is going to give us a fraction. We're going to keep it as a fraction. Okay, so if it is not a whole number, we will keep it as a fraction. So we're going to take the square root of both sides here. And then I got to remember to put my plus or minus in front. And then if you have the negative underneath the radical, we can just go ahead and we can take the I here. Do you guys remember what you can do with a fraction when it comes to taking the square root? Well, you can split it up. So you can do this with multiplication and division. So I can write this as the square root of 5 over the square root of 6. So we did this earlier, but in some of those cases when we did this, in fact I think in all of them that we practiced so far, we had something nice happen. We had a square root on the bottom that was a perfect square. So when we took the square root, it was a whole number. But this time, it's not a whole number. Okay? When we are writing things in simplest form, you cannot have a radical in the denominator. Okay? So we're just going to write a little note. Simplest form cannot contain a radical in the, I'm just going to put denom, not demon, but denom. Sometimes those words look very similar. Okay, so simplest form cannot contain a radical in the denominator. Does anybody remember what we can do so that the denominator is not a radical anymore? Yeah, Maya? Yes, we multiply by the square root of 6 over the square root of 6. Does anybody remember what that's called? Starts with an R. No, but that is a good word. We rationalize. So this is called rationalizing the denominator. So we rationalize the denominator. And so, Maya, how did you know that it was going to be root 6? How did you know?
Because the square root of 6 times the square root of 6 equals regular square.
Yes, good. Okay, so the reason why we do that is all based on what we have on the bottom. Whatever you have on the bottom in the denominator, you multiply that number over itself. The reason why we have to do it to the top and the bottom is I can't just multiply anything I want to, but really when I multiply root 6 over root 6, what's root 6 divided by root 6? 1. So if I multiply anything by 1, does that change the value? No, if I multiply something by 1, I get the same thing. Okay, so we're going to kind of do the what we were doing here, but backwards. Remember how you can split 18 into root 9 times root 2? Okay, we're going to go the other way. Root 9 times root 2 is root 18. So root 5 times root 6 is root 30. Okay, root 6 times root 6 is root 36. And what's the square root of 36? 6. And that's the whole reason why we did that. Okay, like Maya said, root 6 times root 6 is 6. Root 5 times root 5 is 5. Root 20 times root 20 is 20. It's always going to happen like that because you multiply something by itself, it's that number squared. And if you do 6 squared and you take the square root, it undoes it. Okay? So, can I simplify this part? It's kind of a tricky question, right? The rule is, if they're both in radicals, you can simplify. If one's inside and one's outside, you cannot. So I cannot simplify this, even though I really want to divide those, because it would make 5. That would make life happy, whole numbers. But you can't do it. One's in the radical. So your final answer you can write this one of two ways. You can either write it as plus or minus root 30 over 6I, which is how you can see the coefficient. Or if you wrote it as plus or minus I root 30 over 6, I would count that correct as well. Okay, so I would count either one of those as correct. All right, so we're just going to write a little note to ourselves. So whenever you are solving, all of your answers must be exact and simplified. The simplification isn't always stated in the directions, and neither is the exact, but all of what we're doing has to be exact and simplified. If an answer isn't exact, do you know what it does not have? If it's exact, that means your answer should not contain what? Decimals. So exact means no decimals. All right, so we are going to move to the next section, which is about complex conjugates. Okay, this is going to lay the foundation for something that we do later on in Chapter 2. That is something you will also use in your later math classes. Okay, but to find the complex conjugate, there's a special form. So in general, the complex conjugate of any complex number is blank. So first, we have to know the form of a complex number. The form of a complex number is A plus BI. The form of a complex number is A plus BI. Okay, so a complex number contains an imaginary value, and there's also a real value in there as well. The real value is A, the imaginary value is B. The complex conjugate, if you are given A plus BI, is A minus BI. So we're just going to put in words what that means. Okay? So for this, it means the real parts, and in parentheses I'm going to put A, stay the same. Okay, so the real part is A, your A value, that stays the same. While the imaginary part which is B, are opposite. So they change signs. Okay, so the real part stays the same. The imaginary part is the opposite. Okay, so for example 3, we're going to find each complex conjugate. So we have 8 plus 5i. And one thing you want to do is you just want to make sure it is in this form, A plus BI. And once it is, you can pick out the real part and the imaginary part. So we have 8 plus 5i. This is my A value because it's real. This is my B value because it's imaginary. So then my complex conjugate is just A 8 minus 5i. Oops, we have to write the conjugate. Okay, so your conjugate is 8 minus 5i. Now you may think, wow, Ms. Whipple, you really over-explained that. That's because they're not always going to be given to you in the proper form. They could be given to you like this, 2i minus 6. And it would be really tempting to just write 2i plus 6 to change that middle number, but the first thing we're going to do is we're going to write it in the form a plus bi. So if we did that, it's actually negative 6 plus 2i. So now we can see, oh, this is my a value, so that stays the same. This is my b value, so that's what's going to be the opposite. Okay, so your conjugate is negative 6 minus 2i. Okay, so for b, we did rewrite. We did have to rewrite that in a plus bi form. All right, you want to give c a try, 6i? What is the a value in 6i? 0, right? 0 plus 6i. Here's your real value. Here's your imaginary value. Okay, so what do you guys think the conjugate's going to be? So it is 0 plus. So do the opposite. It would be 0 minus 6i, which will just be minus 6i. Okay, so if your real value is 0, you don't have to write that down. You just have to make the sign the opposite. Okay, if you only have the imaginary. All right. Now for D, I want you to try this. It's going to look intimidating, but just break it down. And I want you to write your final answer so that you can see the coefficient of your I value. Okay, so Jack, what's the real part of this?
Would that be negative first?
Yeah, okay, so this is the real part. That's not going to change. Okay, the imaginary part, what I can do is I can rewrite this as negative 1/3 I. And so using our same pattern, even though there were some fractions and some radicals in there, it's the same process. That first value stays the same, and then this is going to be plus 1/3 I. Okay, and if you put plus I over 3, that's fine. I just want you to practice rewriting it so that you can see the coefficient, okay? All right, so I'm going to show you your homework on the calendar and give you some time to do that. I'm still checking some of your 2.4 homework, so leave that on your desk if I haven't checked that yet.